Hello and welcome to the Patreon and YouTube channel members live stream on today, the 7th of April 2019. It's April already, or it'll soon be summer. Then it'll be Christmas again. And I've already started a Christmas project, which I think I might have mentioned. I'm not sure if I did. So here we are. It looks like we've got a few people in the chat anyway. If I disappear or anything bad happens to the live stream as it has in the past, put it in the chat. I'll check on the chat occasionally and answer any questions. So thanks to all YouTube channel members and patrons for your ongoing support. It's really good, and it pretty much is what makes the projects possible, like Henry Hoover pipe organs, but also robot arms and other things, which we'll talk about in a minute. So for anybody new, generally I just go through projects. There's quite a bit that I've made content in advance that hasn't been published yet, or at least, you know, the project's built. There's still a bit of editing to do, whatever, and the video needs polishing off and the thumbnails made and all that stuff. So I'm going to talk about the schedule and talk about, you know, some of the projects and what's going on and the channel strategy and everything like that. So Henry Hoover obviously was intended to be an April the 1st video. I published it on very much into April the 1st UK time, but YouTube still put a timestamp on of March the 31st, so no one was really sure. But nonetheless, views are okay. Retention's not too good on it. It starts kind of high as usual and drops off during the intro. Then it picks up again during the song and drops off very much more. So actually more people, there's higher retention on the intro we did with Moth Cub than there is on the actual song, but that's probably because the song sounds dreadful. And I took this to an event, like a family coding sort of day or technology day called Hack Sutton in Southampton in the UK. I think that was last Saturday, and a 10-year-old pointed out one of my fingers, one of my recorders had the wrong fingering on, which was the E note, and actually it was completely wrong. So it sounds a lot better now, which is a shame. But the way I did it, I can play music. But what I had to do was print out off the internet, when I actually put the fingering on there, was the keys off a piano, and then played them on the MIDI keyboard, and then worked out which valves opened. All these pieces of paper, and then got the recorder fingering, and then followed the pipes and put the stickers on. And somehow I got one of them wrong, which is why it sounds flat quite a lot of the time, and the E note is used quite heavily during the chorus. So that's why it sounds a bit funny. It sounds a lot better now. So hopefully I'll be taking it to future events. But there you go, it's been quite popular. So I'm not sure whether to do another video like that. I would like to make more music stuff, but yeah, anyway, it was good enough for April the 1st. We're Being Africa by Toto and Henry Hoover. So there you go. All right. So we're going to talk about the projects. We'll start with OpenDog, which I've done another episode on, which is due out, and I'm going to look at my schedule. So we have the robot arm that patrons and channel members already have, which is coming out Tuesday, which is part 1 of the robot arm. Then we have the next OpenDog video. So yeah, that's that. Then some other projects, another project, then the Robot Arm 2. So I'm a little bit ahead with this because I finished part 2. But anyway, in terms of OpenDog, it is here. I don't know if you can just see it. Let's see. It's behind me, this new black chair. Here it is. So all I've actually done in the next episode is put the Teensy in. So we took out all those big Arduino Megas, all 3 of them, and I've taken the inertial measurement unit out for now and put in the Teensy 3.6. Not this one, another one. And that's been quite refreshing actually, because now all the code runs on one microcontroller. And it's much easier to tell what on earth's going on. And I've restructured the code slightly and divided it onto separate tabs in the Arduino IDE. So they're all separate INO files. So basically functions, the kinematic model functions being moved to another piece of tab, another file essentially, which appears as another tab. So it's a lot cleaner. And obviously I did the upgrades, the hardware upgrades in the previous episode. So we're kind of ready now to carry on with the development, which is all of the things I wanted to catch up with. So that's sort of turned into 3 videos instead of 1, because I decided I was going to show all that detail. So we're really back to the kinematic model working, but not much else. So we're kind of back to where we were in about part 11, but obviously with all the upgrades, and now it runs a lot faster. So the Teensy is 180 megahertz and it's 32-bit with a floating point unit, whereas the Arduino Megas, of course, are 8-bit and 16 megahertz and all those serial hops. So now it's all in one place. So that's going to make things much better. So several things have to happen next, which is basically, at the moment, the motors try to move to their position at whatever speed you set them to. But because of the kinematic model, some of them have to move further than others, which means some motors get their bit of the joint there before the other one. So when you move the leg or whatever, it kind of moves one and then the other, and they don't quite finish at the same time. So it doesn't draw a straight line with its foot. So the next thing is to solve that, first of all, by motor scaling, to say, let's scale those motor speeds based on the trigonometry. So if there's a shorter distance to go, the motor goes slower. And overall, we'll have a scaling factor so I can make the actual foot move at different speeds. And we'll see how that goes. It still might not draw a straight line. It might draw a curved line. And of course, that makes balancing very difficult. So if that still looks like a real issue, then we'll have to write an interpolation engine that basically maps all the points from point A to point B and goes along them in order. And depending on how fast you go through those points, of course, will also depend on how fast the joint moves. So that's like the next bit of coding that has to be done. Then we can try our trot gate again, where we were walking with diagonal legs. And you'll notice if you look at a lot of robot dog projects, they tend to walk like that. The little MIT cheetah and all of those. There's a few others that have been on social media. They walk with diagonal legs because it's a bit easier to keep balanced, I think. And especially with this robot with heavy legs, it's going to be easier than lifting one foot off the ground, which of course then means it wants to fall down unless it leans right over, which is what I did when I had it statically stable and it's very clunky. So we'll do the trot gate again. And I've been thinking a lot about walking, and I think really what it needs to do is move forward at a rate that stops it tipping down. So rather than trying to balance on the spot as I was before with the inertial measurement unit and picking all diagonal legs up and then trying to balance it by moving it, we're literally going to say, as we take a step forward, just get the speed of those feet right so that it's like leaning on a hoverboard or a Segway. You lean into it, but the board is carrying you underneath and keeps you upright. So we'll have to work out what the right speed is. And first of all, we'll try and do that with dead reckoning. So we'll just basically trial and error the speed the feet have to move back so that it doesn't tip down as it picks up its front foot and brings its balance forward. And after that, we can then go and put an inertial measurement unit in to make it dynamically stable so that it'll alter that speed plus minus if it does tip. So that's basically going to be the progression. So some of that stuff's going to happen in the next part, which will be, I think, part 17. Yeah, so 16 is the next one, doing the microcontroller. There's quite a lot in that episode because I had to change the remote control devices from Bluetooth to the NRF 24L01s for various reasons, and there's some other troubleshooting, moving everything to the Teensy. So it's still a good episode. And then after that, we'll go and work out what we need to do. So yeah, that's OpenDog, and that's what's happening. But basically, I've taken the IMU out for now, so that needs to go back in. And then I think there's going to be like 2 episodes before we actually get a simple being able to locomote properly. All right, let's just have a look in the chat. So there's an IET seminar, 10th of April. Okay, yeah, send the link. That's soon, isn't it? Is it a physical thing or is it an online thing? What's IET? Okay. Can I use smaller time steps? I don't know what that means. What's a time step? Let me just see if I can work out what this means. I have no idea what's a time step, but basically I'm going to. I don't think it'll automatically scale the speeds because they're encoder driven and they're fixed. Whatever it is, I'll have to tell that motor to run at a different speed based on how far it has to travel. So that's because everything's programmed into the O drive. Right, okay, I'm going to just put this link to one side that Neil sent, and I'll have a look at that in a minute. I assume it's online. Is it online? Add to calendar. Google, let's do this. Or do I have to go there? I'm not sure. Okay, let's look at that in a minute and get on with the live stream. But yeah, thanks for that. Okay, we'll let. Right, I'm just going to carry on talking and we'll come back to time steps in a minute. So the other project that you've seen part one of is the robot arm. So I've got onto part two with that. So what you've basically seen is the encoder-driven hub, or two encoder-driven hubs that I got done, and now we've actually got a. Try and make my tripod higher. What we've now got is I've basically made the stand. That was in part one, and now we've got the. That's better. Right, good. So now we've got a motor. Hooray! So this is one of the motors out of Bumblebee, which is one of these fairly substantially sized gearhead planetary drive motors, obviously with 3D printed lovely gear on it, and that's running on the gear that's on the hub. So that's mounted on this aluminium plate, top and bottom, which is 4mm aluminium. And of course, as that turns, it drives the whole arm. And what we've got in there, of course, you saw in part one, are these springs. I've put some more springs in here now. So essentially, this is able to work out the force by depending on how much stretch there is. And what we're going to do, we've got an encoder on the motor that I've basically, you can't quite see it there actually, an encoder on the back of the motor, which I fitted, which I kind of Frankensteined on there. So is actually a Fidgets encoder, which isn't intended to be used with anything else other than Fidgets USB boards. But I worked out what the pinouts are and fitted it on there. So that is what's going on there. So we've got an encoder-driven motor, and then that little encoder, the magnetic, the AMS encoder that I showed in the OpenDog video, we're going to have something very similar to that, probably the exact one, fitted on there. So if you remember from the part one of the video, the actual internal hub is attached to this shaft. So as the internal moves, this moves. So whether we're driving a force back or we're turning the whole motor, this tube moves, and if we measure that, we get the absolute position. So there is a little bit of backlash in this gearbox, but we'll actually know the position here. And we're going to do the same on the other side. So on the second axis, that'll also do the same thing. So that will have the forearm attached to it, essentially. Which will be another thing, and then there'll be a linear slider that goes up and down, that the gripper goes up and down on. So that, again, the outside is now the piece that will have the next axis attached to. And that's how we're going to work out the force on that. So there'll be another motor driving another gear on there. So then based on that, we can basically actively backdrive as we could with the robot gripper that I did. Although in this case, of course, our force each side is equal. There's no bungee stretching more and more as we move the arm in one direction. So we should be able to get the actual force in either direction, and as you pull more, of course, then the gear stretches more. The springs stretch more, so we know we're applying more force. So we've made the whole thing force driven. So that's really it. So part two is basically messing around with encoders, trying to get that to work, making the stand and everything like that. We've got a little motor tensioner thing, so I can adjust the plate there and move the gear in and out and all sorts of stuff. So that's coming up in part two, and part three will be the forearm and hopefully doing some force-driven stuff before we build the gripper. So that's what's going on with that. Yup. So let's return to the chat. Put this back down. Right, what's gone on in the chat? Blah, 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 blah. Okay, so I'm just going to do the comments in order. Have I been looking at deep learning? I'd like to. I did actually, I can't remember if it was you or it's someone else posted the TensorFlow stuff. So I have looked at that yesterday, but I haven't really got into it. I'm not really someone who writes software on a computer. Mostly Arduino is pretty much all I've done. So I did look at TensorFlow. It looks pretty good. It's something I just have to spend a load of time getting into. So yeah, it could be good for this to pick up the sausages and the eggs, have a webcam that can recognize images. So you train it from an image set, and then it will know which orientation your sausage is probably and where it is and whether it's a sausage or an egg or whatever else. And then we can actually have the arm, have a webcam on the scene or a webcam on the arm and have it home in and pick the thing up. To start with, it will be Dead Reckoning, but that's something I'd like to do, but it's just another sitting down and learning it. I used to be quite good at Python script, so I can probably do it if I can remember any of it, but that was many years ago. So yeah, I just need to work out how the API or whatever works and how to actually use it. So I need to go through the tutorials. Right. So just reading this again about time steps. Yeah, so the inverse kinematic model I wrote, and it's just loads of trigonometry. So that's about it. So there isn't anything else to it other than it works out the ball screw length of all of the 3 joints in the leg, the ball screw lengths of all of those 3 actuators in the leg from the XYZ position. So yeah, if I want to do anything else, I'd have to write that in. So then that's essentially what I'm saying is about scaling the motor speed, I think. So I don't have my inverse kinematic models, basically what's explained in those videos, which is me drawing triangles and going on the websites for children to work out trigonometry. So yeah, I don't think I have, there's nothing built into my kinematic model or my inverse kinematic model that's going to take care of that for me. I have to write that in, essentially, is what I'm saying. So yeah. Right, they twisted the word fidget. Oh yes, it's a PH, right. Yeah, so fidgets, they've been around a while, and they've got, so it's basically they've got some Windows software, I think, and some USB boards. You can plug all these interfaces in and do stuff, but there's absolutely no pinout. So they're all right quadrature encoders. They're about £7 in money to buy, and they're only they're 40 CPM optical, but there's just no pinouts. But it's very easy to find out that the red and black wire is power. Then there's 3 wires. One I don't know what it does, and the other 2 are the A and B phase, which is fairly easy to connect to an Arduino and see if those go high or low, and then work out what to do. So that was good. There is a bit of flex at the end of that arm. Well, at least it's force driven. So we're going to be using motion smoothing so that we don't just, move and then, at the moment, yeah, there is. But if we don't make sudden motions, we'll be okay. There is a little bit of a gap with my fingers that grip the 2020 that I need to fix by shimming it slightly. And there's a little bit of backlash in the motor. But basically, we'll be going to using the absolute position for the actual position, and then using motion smoothing with the encoder on the motor to drive it. So I've had it driving fairly okay, but we can't really sort it out till I've got the other axis and then put some sort of load on the end. But yeah, there is a bit of that, but then it has to be force driven. So if it runs into something, it has to stretch those springs so it knows how much force to apply to it, or that it has applied force. So it's kind of more organic, really. It kind of feels its way as it goes. Although, of course, we can just drive it to set positions and we can pull it around and have the motor follow us like we did by back driving the fingers, so we can train it to that position. So that's, I didn't really want to build something totally rigid again, because I've already done that with OpenDog. Otherwise, I'd have used ball screws or linear actuators and made a 6-axis arm, and then I didn't know how interesting that was going to be. And I really quite like to make these things force driven, so it's a bit more fun to it. Right. A good name for the arm, Dead Reckoning. Yeah, okay. I'll remember that one. Don't know, it hasn't got a name yet. Force-driven robot arm projects. All right, so you might have noticed a little Iron Man standing behind me. So the last Avengers film ever apparently is out in a few weeks. It's Avengers Endgame. So apparently that's the last Avengers movie. I don't know what's going to happen after that. But Disney have bought Fox, so I guess they'll be integrating X-Men into stuff. I mean, I don't know, if Tony Stark will come back or what happens in Endgame. So there we go. So there's the week that it comes out, which is sometime around the Tuesday, the 23rd video of this month. I've got another Iron Man project, but it's only little. So already I've found that the Iron Man related project views have increased in my channel. So I think it's worth doing an Iron Man project. So what I've done is made a little Iron Man. Let's just bring this up and have a look down at him, which is hopefully going to fly. So it's the flying Iron Man robot Iron Man. So he's got 4 EDFs. He would have 4. One is here. So the same EDFs I used in the rocket challenge of Ivan Miranda, only I managed to find counter-rotating blades for 2 of them. So yeah, it's all 3D printed. It's got lots of batteries and big power distribution, 4 80 amp EDFs, and it's got servos in it. So let me just squeeze past all this. Now power up some stuff. So my controller is just here, which is an 8-axis, 2 4-axis joysticks, which looks like fun, which is the 3-axis joysticks that do that, and they rotate. And I've also made a 3D printed trigger for them for the throttle on each side. So I'm just going to power up. Yeah, so the plan is to fly by waving his arms around. So as I move these joysticks forward, he moves his forwards, and as I move them this way, he moves his arms around. So it's a bit like, if you saw the Hacksmith interview with Gravity.co, it's a bit like those guys fly with their gas turbines. So I've got, 2 on his back and 1 on each arm, which is a very similar configuration. And that is going to be at least 2 episodes. The first one coming out the week of Endgame, and the next one was going to come out either the next week or 2 weeks later. However, what happened today was I tried to test it because I wanted to see if it flies, or at least lifts, before I put the first video out. The EDF that's missing, I'm not sure what happened, but the motor burnt out and smoke came out of it, and the EDF blade has completely fused itself to the casing. And I'm not sure if I was running it in reverse, because it seems to have pushed the motor backwards, and normally it should suck the motor in as force goes back. And then the EDF blade is completely fused to the thing there, and there's loads of chewed up melted plastic. And then, smoke came out, and it was bad. So I don't know. I think there's definitely enough force, given that these EDFs lifted that whole rocket up, and there are only 3 of them, and now there's 4. But that is the plan. So I was flying it on a tether system, so I had it hooked on 2 bungees from the shoulders. It looked like it was going to lift, but it twisted round, and then it flew around and broke one leg, and then smoke came out. So, yeah. It looks like, though, unfortunately, the parts are on rather a long lead time now. So Hobby King, the EDFs, and the motors are all on about a month lead time. So I'm not going to get those till May. But then the video doesn't go out, the second part, till after that. So it's going to be a bit probably putting the first one out without knowing if it works properly. And at the moment, it's obviously manually driven. The plan may be that we have to put an inertial measurement unit in and try and thrust vector automatically. But I quite like to see if I can fly it manually, just like the Gravity.co guys who just, they wave their arms around. And what they basically said in the Hacksmith video was they try and make a tripod between their arms and the rocket on their back, or the gas turbine on their back. And as you bring your arms in, you get more thrust, and as you put them out, you get less thrust. And it sounds like this one wants to push you forward. So when those are facing forward, you can stabilize, and as you bring your arms back, then you fly forward. And it did want to fly forward quite a lot before the EDF broke, and it may have been running on 3 with 1 sucking, I'm not sure. But anyway, so that project's coming up, because I thought with the last Avengers movie, you've really got to go out with an Iron Man project. So that's what's going on with that little chap. It weighs quite a bit, and there's far too much power consumption. I've got 4 amp hour 60C battery, which isn't enough current for the 480 amp EDFs. But I'm only going to run it for a very short time. So yeah, hopefully that'll be popular, at least the one that goes out that week, and then people hopefully come back for the second one. But there you go. So that is what that's all about. So there's going to be a slightly different schedule where we don't have OpenDog for 4 weeks instead of 3, I think. It depends how that goes. Right. Yes. Right. I'm just going through the comments again. So yeah, Python and TensorFlow. Yeah. So I kind of got that from the tutorials that Python seemed to be the thing. So that's good. Right. Yeah, I wasn't planning to use TensorFlow for OpenDog for any sort of learning to walk or anything like that. It's going to be made to walk by me, but for robot arms recognizing, picking up breakfast items. So the plan is to have the robot arm was kind of started because I wanted to finish the breakfast making machine and put the eggs and the sausages in at the top, then have both breakfast making units and have the arm go and put them in, or maybe take them out and put them on the plate. So having it automatically recognized by vision the breakfast items would be quite good, and pick up a tea bag and make the tea. But yeah, it won't be running on a Teensy. It'll be something higher level, probably my laptop sat next to it. So that seems sensible because yeah, it's vision recognition. I guess you could run it on a Raspberry Pi, but why do that when you've got a laptop that's much better? So yeah. We could, of course, put a Pi on OpenDog one day and recognize, do navigation through TensorFlow, but that's let's get the hardware working first, I think is the plan there. So yeah, all right. Okay, so there's another project as well, which some people who've supported me for a while might remember something about, which is human versus robot. So a couple of years ago, let's just think when this was. So I did a project with Portsmouth University, final year degree students in computer games technology for the Hoverbike project, which was 4 videos. There were 2 of them will be building this lean to steer virtual reality bike. And then there were 2 about students making a virtual reality hoverbike game. And the problem was that they scored quite well, you know, on doing the graphics and the game engine stuff and all of that. But the game wasn't very thrilling because they had a very twisty course. It was very hard to ride. And you know, lean to steer. It had a Vive tracker on it that brought the bike into virtual reality. We had twist grips and all sorts of controls and pedals on it, which controlled the game. But it wasn't very exciting to watch. And generally, virtual reality games aren't very exciting to watch because the person doing it is like they're in another world and it's immersive and amazing. But anyone watching them do it, it's not very exciting, even if you can see what they see. So this year, and the project I actually built last year, they've had it since about September. We thought it'd be good if we have something more interactive. So let me just show you some pictures of what we've done. Let me see if I can share my screen here without cutting everyone off. Right, hopefully you can see. Can you see this picture? I hope everybody can. This is the human versus robot. So there's some CAD. So it's called wheelchair wheels. And basically it drives around and it's got 2 pneumatic arms. I did a proof of concept ages ago for these pneumatic arms, which are actually foot pump pistons, which are in reverse. Good, everyone can see it. So that's the base, which has got a car battery, or it's actually a leisure battery for a caravan, these 2 things. And then we've got this robot with the 2 pistons and actual boxing gloves. And so this is the wheels are encoder driven. We're back to the beginning. Where are my other pictures? Let me see if I can. Blah, 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 blah. Right. Oh, that's another window now. Right, let me just reshare my screen now because the thing hasn't worked. Right, robot versus human. Yeah, so basically it's encoder driven. So the wheels are encoder driven. You send serial data to it to make it punch. And you send serial data to it to drive the wheel position. So you can drive it around and you know how far it's going to travel and stuff. So the students this year have written a virtual reality game, which when you fight a robot in virtual reality, so the shield and your bat, you can just see they've got Vive trackers on the back. So you fight the robot, then the game to move the robot sends serial data to the real robot, which drives around, and when it wants to punch, it sends serial data that makes it punch. And then that has Vive trackers. You might be able to see one on the back of the arm. There's one on the back of each arm and one on its base. And then that is tracked back into virtual reality. And that's what's behind him on the screen here, is this virtual reality game where you see your own bat as you would see the controller, and you see this robot, and when it punches you, you get punched in real life. So yeah, these are pretty bad screen caps. I can't play video in a live stream. It doesn't work. I've tried it before. Yeah, so that's what's going on there. So it's a bit more exciting. Let's just have my camera back. Hopefully I haven't disappeared. It's a bit more exciting because you see someone fighting a robot, and the plan was to 3D print out some of those parts and put them back on the robot, but we didn't get around to that. And the sync between the game and the robot's a bit funny, so there aren't too many gameplay and live caption stuff, but it's always on the projector behind. There's only about 30 seconds of fighting because that's pretty much all it does, and then some stuff about the graphics they did. And it's only one video. It's a 12-minute video about building it, the encoder control, what the students did, and then the fight, and that's it. So it's going to be coming out in a few weeks, I think early May sometime. Yeah, I mean, they're basically limited for time. The university didn't buy the Vive trackers in time. Then there was a big health and safety thing, and everyone had to write a risk assessment. So they didn't actually start on it in September. I don't think they started till this year on the robot interface stuff. So it's not as good as it could have been, but there we go. Although the fighting robot's pretty cool. If we had two of them, the plan was to have two that fight each other, and then we can work out what to do with the game, because that's basically completely unnecessary. And that's why a person fights a robot. So they actually had something to write that's interactive. So it's kind of augmented reality, hyper reality. Not sure which. But yeah, it's a lot more fun than seeing someone on a hover bike. So hopefully that'll do well. But we'll see what happens. There should be more fighting footage, but you know, it's a bit tricky. So, but it looks all right on the video, and there's dramatic music. So that's what's going on with that. Oh, have we lost sync? Have we lost audio sync? It might catch up. There's actually a 15-second delay between the video, what I broadcast, or something like that, and the video. Is my mouth out of sync? Oh, I can't do much about it, unfortunately. It might catch up, or I don't know. If you close it and open it again, I can't do much about it other than stop the broadcast, and I don't want to do that because it'll be a different link then. Pause the video. Oh. I'm raising my right hand now, and now I'm putting my right hand down again. I'm raising my left hand now. Now I'm putting it down again. And in 15 seconds, you'll know whether that was in sync or not. A second out of sync. I'm not sure what to do about it. I can try. Let me share my screen again. Let's just share that again, and then stop sharing. Did that do anything? I'm not sure if I did it. Oh well, it might catch up, or maybe that fixed it. But anyway, I'll face the other way so my mouth isn't out of sync. Seems to work fine on desktop. People on mobile, I don't know. It might be fine. That's weird. Anyway, can't do much about it, I'm afraid. So other things to mention are, I briefly mentioned Henry Hoover. I don't know if I'm going to do any more musical things. I quite like to do a power tool bass line, but I'm not sure how that'll work. And I still need to do something with Tickle Me Elmo. I'm not sure what, but if I do, it'll be something equally offbeat. So I noticed that some Tickle Me Elmos have got, they jump up and down and they've got legs. Mine's got floppy legs and floppy arms. So he seems to be the cheap Tickle Me Elmo, or at least the UK version. So I'm not sure what to do, whether he could play another instrument, but it's not a priority. I don't think we'll do too many more offbeat things. Air cannon for bass. That sounds like it could be good. Some sort of big fan blowing a big cannon. I don't know if I want more air though. It's a challenge because basically I will say I'm going to Maker Central, which is the 11th and 12th of May, Birmingham NEC, if anyone's around. Let's quickly, I'm just going to go on the Maker Central website and we'll talk about that. So I should be there, so definitely, all things being well. Come on, screen share. Where is it? There it is, right. Right, yes, the 11th and 12th of May, and it's at Birmingham NEC, and I should be there. So I had a little booth last year. Should be there this year. Tom Stanton, I think, is going to crash my booth, so that's good. And Ivan Miranda is coming over. So yeah, let's see, where are we? Exhibitors, makers. So we've got not only companies exhibiting. If the link works, no, it doesn't do anything. Colin Furze is going to be there this year. He's got quite a big space. Apparently, he's taking Hulkbuster. He hasn't actually asked me if I'm going to help him control it or whether he's going to do anything or just set it up. So that's good. Bobby Duke Arcs, all these people coming from the US. So 2.4 million subscribers. Bob, I like to make stuff. Jimmy DeResta, Blackbeard Projects, some various others. Hey, there's me. And Ivan's down the list somewhere. And a whole bunch of Laura Kampf, other names you might have heard of. Don't know how many of these are familiar, but anyway, have a look at the website if you're in England. Otherwise, not much point. And then there's a whole bunch of, there were like 100 YouTubers there last time. Some of them, you've never heard of, who just mill around. They had a sort of YouTube zone in the middle, so you could hang out, which is where basically people who weren't that interested weren't sat on the sofas, but it was supposed to be for YouTubers to meet and greet. So yes, I've got a booth again, so I'm going to take Henry Hoover. The only challenge is you only get a 500 watt electrical socket, and a Henry Hoover, the other one that pushes the air, is like 1400 watts or something. So I'm trying to sort out some sort of lower power air blower, because I only need to blow air into a few recorders. So I've ordered one of those electric airbed inflators that's got a battery in and it charges off a main socket. To do that, then I've got, instead of taking my whole keyboard, got a little MIDI synth I've ordered that just puts you to put MIDI in and sound comes out for the accompaniment, and then a pair of speakers, and that's it on my laptop. So I should be able to power that off the main socket. So hopefully I'll be doing that, and some other projects. Haven't really decided what. Not sure what Tom Stanton's bringing to put on the table. I think I've got to take an entire display stand because they're not having shell scheme this year. So I need to take like a set of shelves and a table and all that. But it's only 3 by 3 meters. And yeah, Ivan Miranda's coming over. Hoping to do a collaboration with both of them around that time. It's more of a challenge, and I'm just trying to confirm still if they're both doing it. We've mentioned it, and everyone said that's very nice. But we need 11th, 12th of May. It's in a month. We've got to get building. So hopefully we're going to be doing a 3-way collaboration, but I don't know if that's happening. And hopefully if we don't do it then, we'll do it some other time. And I asked Colin to do it, but he's busy. It involves electronics. Anyway, so we'll see if we do or not. So that would hopefully be a good collaboration and a good event. And there'll hopefully be a video of the events if you're not able to make it. So that's good. Right, how are we doing here? Yes, it was quite good last year. It was very wood turny last year. I think there was only 2 3D printers in the whole place, but I know for a fact there's more makers coming and more people exhibiting and more diverse companies this year with more stuff. So more electronics. Oh, Matt Denton and the Mantis robot, he's going to be there. It'll be static, but it'll be there. So that's good. So he's right in the front entrance where they had the Batmobile last year. So he'll be there with that and his giant Lego, hopefully. So that's good. And he might be part of the challenge thing, but I'm not sure if he's busy as well. I'm not at Maker Faire Hanover, and the reason I was at Maker Faire Hanover 2 years ago, I think it was because they paid for the Mantis robot to go over, and I went out there to help Matt do it. So it's a paid gig. Unless someone's going to pay me to do Europe, then I'm probably not going to go. So not as far as I know, unless if you know anyone who organises Maker Faire Hanover who'd like to expense me out there and pay a small fee, maybe I can get there. But there's so many Maker Fairs. There's Maker Fairs all over the place. And I want to talk more about events as well at the end of my list. But yeah, I'd like to do the Fightbot. Yeah. I don't know if there'll be any more developments because the students have finished their degree. And that's the other challenge. And then next year we'll do it. Apparently another team are doing Hoverbike, but I've not met them. And I don't know if they've produced anything. It's like the less good team. Softer boxing gloves so they can't get hurt and just get out of the VR. Yeah, you could do. I mean, it would work just with as long as your hands were tracked. it would still work. The game would still work. You just would see it instead of seeing in VR. But you know, health and safety, it's hard enough to put a set of shelves up at something, let alone a fighting robot. So yeah, what am I saying here? Yeah, so just briefly touch on yeah, so I did the metal roller. There's definitely more welding coming up. Welding's awesome. So when I need a metal stand, I mean, how would I have made that before? It would have been wood probably. So now we've got, you know, where we need to make the things the right strength. The stand, yeah, it needs to be really sturdy for this. So steel. These plates need to be pretty rigid. Let's make them out of CNC aluminium. And then this can be 3D printed. And then, you know, we're using the right materials in the right place. I'm not going to turn into Colin Firth and make everything out of steel, because that's bonkers. So there will be, I want to make a metal workbench to put I've got a massive vise. It's like an 8-inch jaw that I need to put on something rather than just balancing it on the bench. And I'd quite like to make a metal welding bench that's perfectly flat with like clamp points and everything, so I can use that for welding on instead of a wooden bench. So I'll be sorting out some stuff like that. There might be another video about sorting out the shed and all those things now the summer's here again. So, and you know, I'll be using metalwork throughout other projects where it's needed. So, and that brings me on to this idea. So we mentioned Hanover Maker Faire and various other events. So I was at, in fact, 2 universities this week. I was at Portsmouth doing the fighting robot on, I think, Tuesday. And then on Thursday, I was at Coventry University, which is in the Midlands. And I was doing a talk to students, or 2 talks, in fact. It was various year 1 to 3 degree students, basically about robotics, but they were basically electromechanical engineering students who are, you know, doing their degree, and I was asked to go in and talk to them about the practical side of building stuff. So they've basically done some theory. They've used a thing called LabVIEW, which runs on Windows as far as I can tell, with some sort of USB interface to hardware, but there's no actual code. It's all like nodes that you join together, somewhere between Scratch and something else. So some of them had never written code, some of them had never heard of an Arduino, some of them had never heard of a Raspberry Pi. Not sure which year they were, but you know, all of them were born after I finished my degree, so they've always had the internet, and it's kind of a different world. And there were no lecture theatres. They had basically these massive labs, and then you go and have a class, and the tutor, or as they now call them, had a headset on, and all the students had headsets and mouthpieces, and they all tune into their tutor, and that's how they communicate. So there are like 4 classes going on in this lab at one time, plus me giving this presentation in the corner. And if you miss your train into the university, you can go online now and then put your headset on and do the class. So a completely different world to when I was at university in the 90s, but there we go. So I had to do 2 hour-and-a-half presentations. So it's all stuff about talking about motors and encoders and Arduino and the Arduino libraries and how easy it is. I took BB9E because that's the only thing I've got that works, and I took Robot X, even though it doesn't really work anymore, or at least I didn't really want to have to make it work. And a lot of video and pictures talks about, you know, the Bumblebee build, pneumatics, the hydraulics we used in Hulkbuster, and you know, working my way through projects till they got bigger and bigger. All of the modules, motors, linear actuators, O-drive, brushed and brushless motors, all of that good stuff. So the main issue I had was I didn't have many things to take that I could demo that worked. So, you know, OpenDog I could have taken, but it really only does its kinematic model. When that's walking, I'll be able to take that to places. What I actually want is to build more stuff that's higher quality. I guess like this robot arm would have been good if it was finished. And OpenDog that's got metal in, and I don't rob for parts. So Robot X's arms have had the motors taken out because I took the servos for the breakfast making machine. And, you know, I get asked to do these things quite often, plus a bunch of other random stuff. So I got asked to do this week, oh, can I take a robot that can move its arms and head to do a comedy sketch with another, it's like 5 million subscriber YouTube channel. And I've been asked before, can I bring a robot for a music video, you know, and it's like, oh, what have I got? Well, there's Ultron, but I haven't powered that up for 2 years. And I don't have a manual controller, plus it's a Disney property, so, you know, we'd have to make a new head and all that stuff. So my basic plan is to make a good robot or 2 that I can use for general purpose. And the general consensus, or the most common request, is for a humanoid robot, torso at least, that can do a comedy sketch, can do some dancing, and so on. So basically, I'm going to do a series about a robotic business, which is a robotic hire business and performance business. And it'll start with a robotic torso. and it's going to be well, with a metal stand, some steel stuff, some of the ball screws and the brushless motors like an OpenDog to shift its body around, move its arms up, to move the main axis of the arm, and then I'll work down to DC brushed motors for the other arm axis as we get to the extremities. A head that moves around, and it'll be quite generic. And then basically when someone wants a robot, or I go to a place to do a talk, or Maker Faire comes up, then I've got several things I can provide, which will be a talk about robotics and how they work and all the components, a performance potentially, like a robot dancing performance. So we're going to plan is to make 2 of them, have motion controllers, have little puppets that you can move and the robots move. Of course, we'll be able to sync 2 robots off one data source, or we'll be able to record the motion and play it back. They could interact. They could have, they could do a funny comedy sketch or whatever that just replays, or they could interact with the public or whatever it is, or they could do something bespoke for a specific comedy sketch or DJ performance or music video. And they're going to be open source. And the idea is that anybody can then reproduce them and use them commercially. And I'm aware of the InMove project, which I don't like for 2 reasons. One, it's not open source. It's licensed as Creative Commons non-commercial, so you technically can't use it for any commercial business. Even though I could probably get permission to do so, no one else can. And also it uses RC servos with big gears and worm drive things on them, and the pot's broken out to the joint. So they're not, they make that servo buzzing sound all the time. And what I want to do is use brushless motors, if not the ones in OpenDog, which will be used for the main base axis with ball screws again. Then the smaller sized ones, which that was on the little mini motorbike thing I made. It's quite powerful, still 1500 watts, with a belt drive and some gears that moves the other axis. So it's basically, I'm not using cycloidal gearboxes. I'm going to use normal spur gears and a belt drive. So it's easy to maintain, accessible, and anyone can make it, 3D printed with no real sort of tolerances. But there will be welded steel and there will be CNC aluminium in it. So that's really where I'm going with the metal work, the CNC. And so there'll be a series about building the things. Then there'll be some videos about where did they go. So if I do a Comic-Con, I got asked to go to a Comic-Con, a local Comic-Con, but they were like, well, we can't really pay you, but can you come and you can sell T-shirts and you might make some money, kind of thing. And there's plenty of science festivals and all of that around, Maker Fairs around England and Europe. So it'd be quite good to have a sort of thing that I can take, basically, which someone might pay to see. And then going on from that, there'll be other robots, hopefully. OpenDog will be part of it. The robot arm can be part of it. There could be a whole robot performance. And then I could, of course, make fighting robots that are geared up to punch each other. And there's a ring, and then, you've got like a referee robot, and then you've got people can actually use controllers like in Real Steel to fight them. So there's a lot, of other robots that could be added to that sort of like robot services that you can hire out. And obviously all of it be open source and all of it will be documented on video, as well as the builds and as well as where they go, which helps promote that hire business and also the event or whatever it is that I go to. So it's in a music video, there's a backstory that it's a real robot and not CGI. So that's my plan. That's my next part of the channel strategy. So the next robotics project after this one, when I've got this done, is start building the torso, and I've already started getting the parts together and designing it, which I can show you. I'm going to show you, then I'll come back to the chat. So let me just show you what I've got so far. The idea is it's fairly simplistic and it's going to be fairly easy to maintain, take spare parts, nothing too specialized. Let's share that. Right, so you should be able to see my Fusion 360 CAD view. So we've got a metal stand. I don't think it will be that long in one piece. I think it'll have an attachment so we can put them on a shorter base. Essentially the top part, all of that, less the arm, or at least that part, is effectively the rib cage. And then this piece is where the cod plate would be. So that's the sort of arm of the scale there. And these black boxes are the 4020 V slots, which is what the actuators that I'd put in OpenDog are made of, with ball screws and stuff. So they'll have the same ball screws attached and the brushless motors. So the 2 at the bottom are going to push the joint for the rib cage. So push it that way and also push it this way or any combination thereof. So basically there's a kind of two-way bearing thing here, and this is steel, which is 25 by 25 millimeter, I think, and this is 50/50 box. So we're going to use some of those collar clamps and things. The plates on the front and the back are aluminium, and then again we've got the 40/20 there to make sliders that push the arms up. So it's going to be pretty substantial. Obviously it's open source, so anyone could build that in another way out of extrusion and CNC parts if they wanted, but it's going to be quite rigid just to tack steel together. And as I say, we've got two more actuators pushing up there, which will push the arm out. So that will push the arm axis, and it should be able to get to there. And then obviously we've got another axis that moves the arm that way. So doing that can't quite get above its head. However, it can just turn the arm around, which will be the smaller brushless motor, so it can put its arm right up like that. And then it could, of course, wave its arms in the air, whatever. So we're going to make sure we've got all of that range of motion. There's a lot more design to do on this, and on this arm particularly. But that is the basic concept that I've spent about half a day on so far and I haven't started making. But, you know, just thinking about how that's going to work. So, yeah, what we should be able to do is move those arms around, do all of the stuff, and then we'll have the other axis that can move the arm that way, and the elbow, and maybe a rotating wrist. But to start with, we'll just have sticks. And I guess if someone wants this for a music video or whatever, we can customize it. So, you know, that's an extra fee basically to make a different head or to make different dexterous hands if they need it to do something. And then, you know, those parts can be put back into the business if they're non-exclusive to be hired out. And similarly, there's no body panels. They'll all be 3D printed attached to those plates. So it will have a sort of generic character to start with, and they can be customized in the future for whoever needs them, whether they want it to look like Terminator or they want it to look like a fluffy bear. So that's the basic, the next serious robotics thing that's happening. An OpenDog will be going on in the background. That'll be sort of every 3 weeks. I'm going to try and do that. And these projects will keep rolling on, and I'll have shorter robot things going as we go through. So that's basically what's happening. Right, let's go and have a look in the chat. Will I, where are we? The youth of today, yes. Yeah, I mean, I don't know. When I was at university, I mean, this was before, it was when the internet had just gone public, really. It was like 97, I finished university. And, you know, I spent my time playing with, I did electronic engineering, but I spent my time scavenging computer boards out of skips and messing around with computers and stuff and learning about computers. And then when I went for my first job out of university, I just went for an IT support job because I knew probably more about that, more than other people did anyway, about computers and PC hardware. And that's how I worked in IT for so long. And times are very different to how they are then. My first job was in a computer services company, but they didn't have external email or internet access or a website. And no one really thought that was a problem, you know, no one knew how the internet worked. So the youth of today, quite, you know, it was like hard saying to them, we didn't have the internet really at university. It was there's not much on it. And we had one browser that ran on Windows 3.11 for work groups that crashed all the time. No one really knew what it was. And my email address was like this long. So yeah, it's quite a different world now, I suppose. So there we go. Right, will I soon grow out of space? Yes. I don't know. I really don't know. I mean, the other end of this room has got like Bender's body, the Gonk droid, exosuit legs, and a bunch of other pieces and bits of the first exosuit stacked up in boxes. So there is some space down there to put some stuff. My lounge has got all the droids in and the Lego skateboard and Bumblebee's head still. Behind the camera is the 3D printed bat suit, and in that cupboard is the 3D printed alien suit. Yeah, it's getting pretty crowded actually. There's still a spare room that guests stay in. And that's got a few things in, but there's more space. Henry Hoover was in there. So I don't know what to do really. I think that some stuff is going to have to go and live somewhere else. I mean, like Ultron is nice standing there, but when I've got my new human torsos, I'd rather have them behind me. So he'll have to relocate. His arms come off and stuff, so I might be able to put it somewhere, but it's just a challenge with this, the ceiling in this place being sloped. I can't put anything at the sides because it's too tall and you can't stand it there. So yeah, I don't really know what to do. It's a challenge. We should get a new house really, shouldn't I, have a garage, but that's a challenge. I don't know. I don't have an answer, but yeah, I'm aware of it. How is it possible electronical? Yeah, I mean, electromechanical degree, they've like two. I literally said, who's heard of an Arduino? And like 3 people out of 30 put their hand up. The same for a Raspberry Pi. And the one person who knew what it was had watched my channel and watched and knew who Colin Furze was, and no one else really knew who Colin Furze was. So that's like the one person who's investigated stuff for themselves and has interests that are their degree. And everyone else, I don't know, just happy to be taught what they learn. And someone came up afterwards and was like, wow, this Arduino is great with all these libraries and all these modules, and you can just like add a soundboard and add the library and play the sound. But can I do it without coding? You know, can I do it more like LabVIEW, this graphical thing? It's like, why don't you just learn coding? You know, what's going to happen when you go to an employer? You're not going to use LabVIEW then, are you? Like you go and work in the toy industry and they want a prototype, you're going to have to get out an Arduino and put some code on. But yeah, I don't know. That's just the mentality, I guess. It's pretty surprising, but don't know. Yeah, there we go. It is strange. More robots, great. C3PO torso. Yeah, I mean that's possible if someone wants that, or you know that's the other thing for sponsored deals. Like I don't know if someone comes along and they want some specific character, it's much easier to do that deal rather than building it from scratch. Oh, I've got to build this whole robot. Oh, we'll just make the panels for the character and put them on. So I think that'll bring in some other brand sponsorships as well, even if it is a, you know, for advertising and then there's a backstory or whatever it is, or they just want a robot that makes breakfast or makes coffee, like coffee brand, whoever, kitchen cookware brand. Oh, I can make my robot use your pots and pans. You know, there's a ready-made, I've got these general purpose robots that can do stuff and can do product placements. Good. Oh, we're back in sync. Any further collabs? No, only mentioned potentially Ivan Miranda and Tom Stanton both at once, if they want to do it, which I'm still trying to confirm. Otherwise, I probably will do something with them, something else with them. Tom Stanton doesn't live far away, actually. He only lives an hour's drive away, so hopefully I'll do something with him. It's just I think he's concentrating on his content, and I've got a lot on, and it's a bit tricky. I was going to go to Germany and do something with Laura Kampf, but I wanted to do so she got a boat out of a sunken boat and patched it up and made an outboard out of a drill. And I wanted to make it speech driven. So I had a wiper motor and a chain or whatever that pulled the tiller so we could steer by speaking into a microphone, but she didn't want to do it. So I don't know. I could sell some stuff to the fans, but it's a bit of a problem because none of it's, you know, like Ultron's pretty clanky and I don't know if I can really sell it. I'd rather not have the liability or the questions about making it work and all that because it's, you know, still got for some of the feedback pots held on with double-sided tape and dodgy things. So yeah, don't know about that. Right, what else is on my list? I think that's everything, and it's nearly an hour. Oh yeah, so I do still have a 16-hour-a-week day job, which I do working from home whenever I want flexibly. And that, I think I mentioned it before, it's basically a distributed manufacturing business, which does two things. One is a sort of 3D hubs replacement. So 3D hubs, you used to be able to register your own printer and accept print jobs and fulfill them and send them back and charge someone and sell the physical print to them. But then they dumped all their users and now they only partner with industry partners. So one of the things it does is what 3D hubs used to do, but that's not the main business. The main business is hopefully that people will sell actual products on that they've invented. So the current functionality, we've actually just launched the website, although it's not been advertised and it's still really in testing, but it is publicly there. And you can register an account and set up your printing hub effectively and also sell a product. So you can list a product with subcomponents, which is like a 3D printed. In fact, here's a thing I made for it. I showed some people a robot I made a while ago, which is down there. But yeah, basically, this is a 3D printed lamp product. So all of these pieces have got screw threads that screw together. And obviously then you can have a customizable shade and it's, you know, and you can build this whole thing. It's like a construction set. Let's just unscrew. Oh, I can't quite do it. But anyway, all of the pieces, like the curves and the joints, they're all like screw together pieces that screw together with a screw thread. So the idea is you make your own desk lamp and you print the pieces you want and you put it together how you want, and you either put RGB LEDs in or you make a smart home device. At the moment, there's no electronics. There's space in the base for a dimmer switch at the moment. And you can have a base with 3 stalks or 1 stalk. It could just go straight up with a bulb or, you know, a diffuser on the end. It doesn't have to be that shape. It could be customizable as long as it's got the screw thread on. So that's one product which is listed on there, I think. And the other product is these little robots, which I did show patrons on a previous live stream, which has got a Raspberry Pi and an Arduino in it, and some wheels, and it's running My Robot Lab, which is open source software. That's a Java program that runs on the Pi. So that's listed on there. I'm not sure if all the parts are listed. I think they probably are, actually. You can probably go and download the CAD for it now. Anyway, the aim is, the eventual aim is that the people designing the products will be able to partner with someone to fulfill the parts, not only 3D prints, but the components. And that takes the load off the designer. So instead of having to go, oh, I've invented this cool thing, it's a pipe organ. But if I want to sell them, that's a lot of effort making all those prints or going to a factory and producing, you know, the valve block or whatever. Or I've made a robot arm. Some people might be interested in buying them, but I don't really want to have to manufacture them. It kind of takes the load off the designer. So the designer can then partner with someone through the website to fulfill the 3D prints and either send them straight to the person who buys the product or to send it to the designer so they can check them and send them on with the electronics kit. Or they could just say the person prints it themselves and I'll sell you the electronics kit. So there's various options. Anyway, so it's still, the partnerships thing hasn't been built yet. So far, we've got, you can list a product with components, and we've got, you can set up a 3D printing hub. Anyway, the website is umaker.com, umakr.com. If anyone wants to have a look at it, it's public. We're not really mass advertising it yet because there's still things to be built and there's still some problems to iron out. It's also not running HTTPS yet. It needs the SSL certificate applying to it, so it's not actually secure yet in terms of, you know, end to end, but it's functional and you can register an account and have a look if you'd like to. So that will be in my, I will be actually doing a series about OpenBot in my channel when we're ready, and saying everyone can get it on UMaker at some point, hopefully later this year. So that is still going on. Yep. So yeah, if anyone wants to have a look, feel free to go and have a look and register an account and let me know what you think if you like. Yeah, so that's pretty much everything I've got. If anyone has any questions, then let me know and I will endeavour to answer them. Otherwise, I'll give it a few more minutes. Not sure if I want this lamp in my house, but it could be very nice. It doesn't have to be black and yellow, obviously, you can have any colour. And the whole idea is, of course, with 3D printing, it's customizable, so you could download just the bits you want and then you can make it how you want. Or you could redesign another piece and upload that if you wanted. You don't have to make things open source, of course. People can... Oh, I can't put this away now. You could have something that you don't list the parts for and you only partner with specific people to fulfill them, and then you take a royalty. Or you could make it open source and give it away and someone else can sell it, as well as doing a print fulfillment business. They can list it as another product they've modified and sold, like proper open source. So there we go. Yep, have a look at that. So yeah, obviously I'm employed by that business, so I have some interest in it. But there you go. Right, what am I taking to NEC? I am going to take Henry Hoover, and I don't know anything else. It depends. I might take this robot arm. I could do some floor standing stuff because I don't have, well, I have to take tables otherwise. So that might be quite good to take. If I can get the next axis on in the next video, make it force controlled, and I can demo training it, that'll be quite good. Right, am I getting the Pro model from Lulzbot? I don't think I am. I'm not really sure what they're doing with that. I am talking to Lulzbot at the moment about the support they give me, and that's all I'll say. They haven't offered me one, and I'm not sure if it's intended for hobbyists, really. The TAS 7 is still a printer which hasn't come out yet, which is coming out later this year. We should have the features of the Mini 2, so I believe it's going to have the E3D Aero extruder and the belt-driven Z-axis and all of that stuff. So that's essentially the progression. They seem to have brought this out as more of an industrial printer with the dual extruders, and it lifts the nozzles as well in between prints. So I'm not sure, really. I haven't heard that I'm getting one. So there we go. But we'll see what happens with the TAS 7. All right. Okay. All right, I'm just going to wait a few minutes for any more questions, and then I will end the live stream. But I'm always available for questions. If anyone has anything, you can post it on the Patreon wall, or you can, I don't know if you can post on my community wall, but you can reply to comments on my YouTube community wall if you're a YouTube channel member. And on Patreon, of course, you can post it on the wall, or you can write comments in response to my post, or you can message me, I think. What is the URL of the site I'm working on in my day job? Let's actually go on. I'll show you the actual website. How about that? It's UMaker. Oh, that's not it. UMaker.com. It was going to be iMaker, but that's already gone. So let me share my screen here. We'll show you. It's this, I think. There's a massive animation video on the front page. But yeah, it's UMaker.com. YOUMAKR.com. Oh yeah, there's OpenBot. There's that skateboard I did. There's another project I did, which is a drone you fly by waving your hands, where you've got a glove and then you can fly it. So there's the components are listed there, which was a drone that I bought off the shelf that's got quite good control. Some servos. Actually, it's got a cradle that moves the sticks of the remotes when you move your hands. The Arduino. What's that? The Pro Mini. A flex sensor, so you bend your finger either way up, and it knows to fly up or down because of a tilt switch, and various other things that are in there. The battery and so on. Yes, and the inertial measurement unit, which of course you tilt your hand to fly left and right and backwards and forwards. And there should be some 3D files. No, they're not there. Anyway, the 3D files are a component generally, so you can download them and print them, or you don't have to. Yeah, so here we go. Make it yourself, just the electronics. Someone else prints it. I'm not sure if that's the right price, but this is sort of a test listing. Order it ready, and that's everything is provided. Someone else or the inventor prints it, which actually I didn't list this. Someone else in the company listed it. But then it would just arrive as a kit already made. Not sure which. But yeah, there's a number of other products listed. So let's go. Most of them are tests because lots of the people are just testers at the moment. So there's a few weird things. I'm not sure what this pollution controller is, but turn your bike into an e-bike. That's another thing that I designed. So my role has been seeding the website with designs. So yeah, making this thing that sits on the back wheel of your bike, it turns it and rubs on the back wheel and turns it into an e-bike. So that's another thing there. And I'm not sure if the components are listed. No, they haven't been listed yet. So yeah, and then you've obviously got this 3D printing system where you can upload your prints and then you can search for people and see if there's only a few test users. We really need to get some more users on there who want to fulfill prints, but you can get a quote for your print and then send it off. The person can review it, accept the price or not, and then they can fulfill the print and send it to you, and so on and so on. So yeah, have a look if you want to have a look, and feel free to create an account and play around with it. All right, so that is it. So the HTTPS, we have the certificate, but the web development guys need time to apply it, and we don't want to take the website down to do it at the moment because there are testers and there's also potentially investors who want to see it running. So I don't know, but it's almost ready to go. But it will be HTTPS throughout. That's all I can say at the moment. So yeah, all right. So coming soon. And hopefully I'll be saying more about it in my YouTube channel once we've got most of it up and running, and there'll be a big press release and all that good stuff. Yep. So yeah, all right. And if anyone's got any suggestions or something, then let me know. We do have some beta testers having a look at the moment, volunteers. We can't afford to pay any beta testers, but there we go. We'll be opening it up more publicly soon. All right. Well, I can't really account for the web design company, so yes, I don't know. Not sure what the delay is exactly in terms of the time they think they need to apply it, but there we go. All right, I think that's it. So I'm going to end the live stream, and thank you very much. And if there's any questions, let me know and I'll do my best to answer them. All right, cheerio.